Okay, here we go. Use sigma notation to write the sum. Right? We have a finite n. This is a finite sum. It's a partial sum, right? It's not dot, dot, dot after. It's saying this is the last term. Okay? We've talked about how when you have a fraction, that is your sequence, or in this case, a series, because we're adding these things. Just a very, very semantic, very close semantics, but we're calling this a series instead of a sequence because there's plus signs instead of commas. But we've said when you have a fraction, treat this as a numerator and denominator. Don't treat it as what's happening to the overall fraction. Right? So for this rule, we're supposed to come up with sigma notation. Sigma notation says, tell me where to start, tell me what number I plug in when to stop, and tell me what rule I'm plugging these numbers into. Right? So we're saying that this is the first term, we're saying that this is the second term, and we're saying that this is the third term, so on and so forth. What term is this? I'm not sure. Okay? But I should be able to come up with my rule just based on a few of these terms that are written down. Okay? And again, where do I start and where do I stop? I'm going to say that this starts at 1. I don't know where it stops because I don't know what I plug in to get these two numbers. Right? So we've got to fill this space in. We're going to start with 1. You can start with 0. We've had a few of those. Be careful with that. Okay? Now with this, what do you notice about the numerator? How is the numerator changing? It is not. Okay. Now look at what's happening in the denominator. How do I get these two values from an input of 1? And before you answer that question, how do I get these two answers with an input of 2? Because it has to be the same. Whatever I do to this to get these, I have to do the exact same thing to this to get those. So clearly you can see in the first term this is a 1, in the second term this is a 2, in the third term this is a 3. So the basic bones of this problem are a 1 in the top and 2 numbers that are multiplied together in the bottom. It looks to me as though the first number is the term number. So I'm calling this n. The second number is what? Look at what do I do to 1 to get 3? What do I do to 2 to get 4? What do I do to 3 to get 5? So how am I getting this second number in each one of these? This number is always 2 more than that, and that's the same as that number. So if I plug an n here, this number has to be 2 more than that. I'll call this n plus 2. So this is the rule that I'm using to come up with these values. I started by plugging in the number 1. This was the last thing I got. That was the result of plugging in what? Well, match it up. I got a 10 here. What was supposed to go there? N. So n equals 10, which means I stopped when I plugged in the number 10. Okay, remember, with these sequences, how many times have we said this now? You're looking at this as the input. What am I doing to this to get these numbers that are changing? If it's not arithmetic, if it's not geometric, you've got to think, this is the first term. What do I do to 1 to get that? What do I do to 2 to get that? What do I do to 3 to get that? I just plug it in. That's why that's n. And then look at all the other numbers that are changing. This is changing. How is it changing? This is always 2 more than that. This is always 2 more than that. This is always 2 more than that. So I'm multiplying n times 2 to get that second number.